I'm quickly going to do, this is exercise 8.9, question C. Okay, so the first question, let's just read that question. A, B, and C are concyclic. BA produced meets the tangent through C, and PQ is equal to PC. So that means that this angle is equal to C4 over there. Okay, so I am looking in the first question, show that ACQP, show that this is a cyclic quadrilateral. Now, if I have a look, I can do an exterior angle, so I can do A1 is equal to Q1 plus Q2, or I can even do the butterfly, which is the angles in same segment. Let me just label this is P1 and P2. So let's have a look. I have a tangent that's been given to me, so that's where I'm going to start. So I'm going to say, let's quickly follow there. So let's have a look. I'm actually going to use this angle here. So I'm going to say angle, this is question 1. So I'm going to say angle C1 is equal to angle A1, because there my tangent goes and ends. That's tan chord is my reason. Then I know that C1 is equal to C4. These vertically opposite angles. And then I know that C4 is equal to Q1 plus Q2, because I have an isosceles triangle, because PC is equal to PQ has been given to me. Now, I never use isosceles triangle without stating what is equal and why it's equal. This is actually 2 reasons in one for me, so I write it like that. There, I've now proven that A1 is equal to Q1 plus Q2, and therefore ACQP is a cyclic quadrilateral. Now, why is it a cyclic quadrilateral? Because the exterior angle is equal to the interior opposite angle. Right. Now let's have a look at question 2. Question 2 asks me to prove that PQ, so this is what I have to prove. I have to prove that PQ squared is equal to PA times PB. So let's have a look. This is what I have to prove. PQ squared. So this 2 I usually see as it's 2 triangles sharing PQ. So there's my PQ. Now I'm also looking for PA. PA is there. And then I'm also looking for BP, which is there. So I'm going to work in triangle APQ. And I'm going to work in triangle BPQ. Right. So ABQ. So let's have a look. So I know that A3 is equal to C4. What do I also know? ABQ. And then I also have BBQ. ABQ A, B, Q, B, B, Q. So they both share an angle. So angle B1 plus angle B2 in this triangle is equal to angle B1 plus angle B2 in that triangle. That is a common angle. Then I know that BPQ and APQ. So I'm now looking for, let's write the angles down quickly. AB, I have there, ABQ. So maybe I'm looking for something with a Q1. So Q1 in this triangle, and then I'm looking for something that A3 will be equal to. So Q1, I can see over here. There's my butterfly. And remember, you will never prove a cyclic quad unless you're going to use it. So Q1, so let's start there. Q1 is actually equal to C3. Okay, it's angles in same segment, and I can now use that reason because I've proven a cyclic quad. Then I'm just going to scratch this out. Then I know that C3, there's my tangent, is equal to B. That's a tangent chord. Therefore, Q1 in this triangle is equal to angle B. And now I can say, therefore, A3 in triangle APQ is equal to, and the only one that's left is this big one, Q1 plus Q2. That's angles in a triangle. So therefore, triangle, let's start with A, B, Q. A is equal to, similar. A is equal to Q. B is equal to P. And then B is equal to Q there. Angle, angle, angle. So let's have a look. Now I have AP over QP is equal to PQ over PB is equal to IQ over QB, and this is the one that I want. Therefore, AB times BB is equal to BQ squared. Okay, I'm now going to do question 3. So question 3, let me just quickly sketch this again over here. I'll just quickly do it. Okay, there's my tangent. Oops, daisy. Okay, the next question, they say prove that PQ is a tangent through circle ABQ. So there's actually an imaginary circle there. So what I actually have to prove is this is a tangent. If I just extend to that, I have to prove that, let me just move it here. I have to prove that B1 is equal to angle B, or Q1 is equal to angle B. So that's actually what I have to prove. I have to prove that Q1 is equal to angle B. And haven't I done that already? Here in my previous question, I have proven that Q1 is equal to B. So I can just say that Q1 is equal to B. I have proven it already from this similarity, from triangle ABQ similar to triangle QPB. Therefore, PQ is a tangent to the circle ABQ. And what's my reason? My reason is angle between tangent and chord is equal to the angle in the alternate or the alternate segment. Okay, right. Now, question 4, they ask me to prove that AC over BC is equal to BC times AP over PQ squared. Now, I have proven PQ squared equals to what? I've proven that in question 2. Question 2, I have proven that PQ squared is equal to PA times PB. I have proven that. I've proven that already. So they are actually asking me, so what are they asking me? They're asking me actually to prove that AC over BC is equal to PC over BB. So AC, so let's go to our triangle. AC is here. BC is here. PC is here. And PB is there. Do you see those two triangles that we have to use? So I'm going to use triangle BBC because I'm talking about PB there. BBC and triangle ABC. These are the two triangles that I'm going to do. What you can also do, you can also shuffle them a bit around. And if you do this, so I literally just went and cross multiplied them. This is triangle ABC and this is triangle BC. There's already a B there, BCP. That's actually how I found my two triangles. So let's have a look. BPC and APC. So first of all, they share an angle. It is a common angle that they are sharing. Okay. And APC, I know that C3, BPC, sorry, I have to start with B here. B is equal to C3 in triangle APC. How do I know that? Tangent chord, but I've actually also proven that already. And then what I have left is this angle here. C2 plus C3 is equal to BC, and that's A2 plus A3. That's A2 plus A3. That's angles in a triangle for my last reason. Therefore, triangle BBC is similar to B goes with B goes with C, and C goes with A. And now remember, all that I'm looking for is either this or this. It's the same thing. So BB over BC is equal to BC over CA is equal to BC over BA. So let's have a look. AC, BC, PC, PC and PB. So this is the one that I'm looking for. Therefore, I have already there, if I just shuffle them around, AC over BC is equal to BC over PB. I have proven it, and then I just usually copy that last one down. Therefore, AC over BC is equal to, and the question was, PC times AP over PQ squared. I have substituted in PQ squared there. So I have explained everything there. I've substituted PQ in there. So this is what I had to prove, and I did just exactly that.